Module 2 says to show that sine 2 theta. It says that express vector AB and vector BC in the form xi plus yj plus zk. All right, so let's do this question. Let's make space over here. All right, we don't need to be wasting any space. So we have it that vector AB is OB minus OA. All right, vector AB is OB minus OA. OB minus OA, that's just going to be, looking at the coordinates, it's going to be OB is 1, 2, minus 4. That's vector OB. And we're subtracting vector OA. Vector OA is 3, minus 1, 2. Doing this easy subtraction, we get that vector AB is 1 minus 3, which is minus 2. 2 minus minus 1, minus 1, that becomes 3. Then minus 4 minus 2, which is minus 6. That's vector AB. Nice and easy. Next we need is vector BC. Vector BC is going to be equal to vector OC minus vector OB. So vector BC is vector OC minus OB. Nice and easy. Now since this is vector BC, OC minus OB, then let's go ahead and do it. Vector OC is minus 1, 1, minus 2. And then we're going to subtract vector OB. And vector OB is 1, 2, minus 4. Nice. So let's go ahead and do this subtraction. Oh, remember they said they want it in IJK form, so I don't want it to lose any marks. Let's rewrite it as 2i plus 3j minus 6k. Don't want it to lose any marks. So 1 minus 1 minus 1 minus 1 is minus 2. Let's put I already. 1 minus 2. 1 minus 2 is minus 1. J. Then minus 2 minus minus 4 is 4 minus 2, which is plus 2k. That's vector BC. All right. Nice. Now it says, show that vector R is perpendicular to the plane through A, B, and C. So what I'm going to do is, let's say this is plane. Let's say this is the plane with the different points A, B, and C. All right. If that is a plane through A, B, and C, and then you have this line, which is vector R. Let's say this is vector R, and this is the plane. We need to show that the plane is perpendicular to this line. So you have the points A, B, and C. I'm just making up some stuff here. This could be A, this could be B, this could be C. Now, if the plane and this line is perpendicular, then that means that any two lines or direction in the plane, that means vector AB and vector BC must be perpendicular to this line as well. And if they're perpendicular, then all we need to show is that R dot AB, we need to show that this is 0. And we need to also show that R dot BC is 0. If the dot product for both of these lines are 0, then hence this vector is perpendicular to the plane. So let's go ahead and show this. This is what we need to show. So let's try to do that now. Vector r as we see is 0, minus 16, minus 8, and we're taking it with the dot product of vector AB, and the dot product of vector AB is minus 2, 3, minus 6. This is minus 2, 3, minus 6. Taking it with the dot product, we're getting 0 dot minus 2. 0 times minus 2 is 0. Then I get minus 16 times 3. And you're getting minus 8 times minus 6, that is plus 48. And this is working out to be 0. So absolutely, yes. So far they're perpendicular. All right. Let's try this one now. R dot BC. R dot BC is 0, minus 16, minus 8, dot BC. And what is vector BC? Vector BC is minus 2, minus 1, 2. Minus 2, minus 1, 2. That's equal to 0 times minus 2 is 0. Minus 16 times minus 1 is plus 16. Then minus 8 times 2 is minus 16. And all of this work out to be 0. All right, so hence, so now we can conclude, hence, R is perpendicular to the plane. So we can make our conclusion that R is perpendicular to the plane. Next thing it asks now is to hence find the Cartesian equation of the plane. Now, in order to do this, in order to find the vector equation first, we need a normal. Now, since R is perpendicular to the plane, then R can be a normal to the plane. All right, since R is perpendicular to the plane, then R can be a normal to the plane. Then we know that the vector equation of any plane is R dot n is equal to E dot n. All right, and so it works out to be R dot n. In this case, n is 0, minus 16, minus 8, and that's equal to A dot n, where A is a known point on the plane. You can use any one of the 3 points on the plane. So A, you can use either B, point B, you can use point A, or you can use point C. Let's say you want to use point B, 1, 2, minus 4. 1, 2, minus 4, dot n, and n is 0, minus 16, minus 8. So working out this dot product, we're going to get 0 plus 32 minus 32. This is going to be working out to be minus 32 plus 32, which is equal to 0. And so hence, that implies that the Cartesian equation is going to be, remember R in general, remember what R stands for. R stands for X, Y, Z. So in reality, R stands for X, Y, z. And so the Cartesian equation is going to be 0 times x is 0. So it's minus 16y minus 8z is equal to 0. That's the equation of the plane. We can divide through by negative 8 to say that the plane really and truly is 2y plus z equals 0. All right, that's the equation of the plane. That's a Cartesian equation of the plane. Nice and easy, soft. Now that we have the Cartesian equation of the plane, we're good. We're absolutely good.